You know, the newest estimates, the cost of PRRS, annual cost of PRRS, when you add the hard costs and the soft costs together, is almost $1 billion a year is what we estimate PRRS cost our industry. So it's still the most important disease of pigs. It's economically the most important, and it has been for a long time, even though we took a little bit of a break with the circovirus problem that started in 2005 with the vaccines have really conquered that disease by and large. So we're back to most of our focus as an industry is certainly on PRRS. I took this picture in December of 1986. This was the first PRRS outbreak I saw, and you can tell, you know, we got black and white pigs here, and you don't see many of those today out in the industry. But so we've been fighting this thing since 86, 87, and we're really starting to make some progress, and that's kind of the. So I'm going to talk a little bit about advancing knowledge, and we have advanced a lot, especially in the last 10 years on getting closer and closer to control or eradication. And we've got new tools. I'll talk a little bit about those. I've got 2 or 3 slides I threw in there on how we eliminate PRRS in the field, and this has become very standard in our industry. We know how to get rid of the virus from a standalone farm with or without vaccine, and we'll talk about that just briefly. And then Lisa asked me to really focus a lot on transport biosecurity, and I've got quite a bit of experience with transport biosecurity over the years, and so I've got quite a few slides on that. We'll talk about that. And then a little bit about the ropes and the way we're monitoring for PRRS now out in the field, which I think is a lot friendlier than snaring and bleeding a lot of pigs, even though that tool hasn't gone away either. So this is kind of where we've been. I've used this slide every now and then. I found that on the internet, but I really think that, you know, we've had so much confusion about and a lot of about every year there's this new silver bullet control method or something that comes out in the magazines, and we all tried, and then after a year or two we're pretty disappointed. And so our roadmap is not really pointed all of us in the same direction at the same time, but I really think we're starting to get to a roadmap for PRRS that makes some sense, and a lot of people are working and getting there. So that's an old slide, but so the recent advancements, both in the field and in the research hand, elimination strategies have really been worked out. We started eliminating PRRS in 1998 when I was at Pig Improvement Company, and by 2000, 2001 or 2, we had eliminated PRRS from all of our multiplication, and I led the team that did that. Monse Torre-Morel from University of Minnesota, and she's back at Minnesota now, really led that charge. Marie Grammer at University of Minnesota worked for us then. And so we basically worked out all the elimination strategies, the early elimination strategies, without depopping farms while I was there. And then those have advanced as those methods got out to the industry. A lot of people have done a lot of new things with that and made it work. And so talk about the importance of transport. We'll spend time on that, I said. And we know that this virus is fairly easy to transmit, especially in the winter, the cold months. People, trucks, any cut boards, anything you use that has contact with pig can track this virus to other pigs if they're exposed to it. And we know that people and trucks are probably big ways the virus moves around. And then, of course, in high dense areas, aerosol. But aerosol is probably, we don't think it's the primary route transmission for this virus. We think it's a very minor way the virus moves around, except when you've got hundreds of thousands of pigs all in the same mile or two of your farm, and then it has opportunities. So, and the filtration, understanding aerosols has really occurred. Scott D has led the charge on this for the last few years, done a lot of studies and we know aerosols exist, and we've looked at the filtration. We know filters seem to work in these high-risk areas. The bore studs in this country were the first to filter, and almost all the major bore studs are filtered unless they're sitting in the middle of nowhere as far as pigs are concerned. And so filtration is a tool that we can use as producers, especially if you're building a new farm and you're building in Washington County, Iowa, or the northwestern Iowa, where we have so many pigs. And a sow farm, I would consider designing my building with filters. So enough said about that. We have more vaccines on the market today. Pfizer launched their vaccine a month or two back. So we've got another modified live vaccine that we can experiment with and try to figure out how to use. Boehringer Ingelheim has done many studies on their products, and we know now better ways to use those vaccines to get more out of them, especially if we're moving negative pigs to positive areas, high-risk areas. We know if we vaccinate those pigs ahead of time, survival, feed efficiency, growth rates, everything are improved when they're challenged with field virus if they're previously vaccinated with about a 30-day period in there. So we're learning. There's some killed vaccines on the market. MJ Biologics has a different approach at working with their customers and their vets, and they try to match their vaccine to the antigenic, how the virus works, and with the immune system. And so we've got a lot of testimonials, not a lot of research, but I've talked to a lot of friends that are veterinarians in the field that really are starting to believe that this vaccine makes a difference in sow farms. So we do have different vaccines. Probably one of the biggest advancements that's right on the horizon is this big pig study is the genetic resistance. We've identified all the major breeding stock companies have pigs that are genetically resistant to PRRS. And not only resistant, but some of these pigs are also resilient. So, so they're tolerant and they don't get sick even when they get PRRS. So we think in the next few years that this may be one of those real breakthroughs will really help us eliminate the virus or control it. PADD is a risk assessment tool was funded by National Pork Board, and this has become the gold standard of biosecurity benchmarking for our farms. And almost all the regional control projects are using PADD to benchmark the biosecurity risk factors with individual farms. And so if you haven't done this, you need to get with your veterinarian and talk to them about maybe I should do this risk assessment to see where I am compared to people that are staying negative. The better test, really our testing ability since the first test came out, I think in 92, 93, the old IFA test, which was a terrible test, and we had huge numbers of false positives with that test and then lots of false negatives. But since that time, we've really got some really good tests. And we'll talk a little bit about oral fluids that Dr. Zimmerman at Iowa State's really championed, and his grad students have done a lot of research with that. And we're really making some real progress. And these last two probably don't mean much right now, but we've really advanced our knowledge on how this virus affects the immune system of the pig, and we've also learned how the immune system of the pig works against this virus. Well, so what? But if we're ever going to have a vaccine that really gives us a good broad cross protection, is a highly effective vaccine, this is the kind of stuff we have to figure out to get there. And so in the last 2 or 3 years, we've made huge advances in this area. So although I think we're still anywhere from 5 to 10 years away from this ideal vaccine, I think we'll get there someday because of the knowledge that's been gained the last few years, mainly supported by the National Pork Board. So where does this lead us? I was at the PRRS CAP meeting this week, which funds a lot of the field research projects. Dr. Bob Rowland and Dr. Bob Morrison are leading the charge with about $500,000 originally from USDA, and that's what the PRRS cap was all about. And I don't remember, Lisa, you were there, was it Bob Rowland or Bob Morrison? One of them said this whole PRRS process has been a series of 2 steps forward and then sliding 1 step back. And so, in the early days, we made it 2 steps forward and slid 4 or 5 back. So at least we're getting to that point where we are steadily making progress, even though every November it seems like we have setbacks. The virus recirculates in spite of what we do. I think the big thing that's happening is we're really starting to get a lot of producer interest and producer engagement. All these PRRS control projects are producer driven. Now, veterinarians have tried to help and organize, but really every one of those have picked key producers in an area to drive these projects and keep the communication and everything going. And so that's a big difference. The other thing too is the government's not involved. It's all, it's up to us, the producers, to do this disease. And most of us just assume the government didn't get involved, because that really creates some headaches that we don't want to deal with. But when I talk about biosecurity, I talk about bioexclusion, biocontainment, and biomanagement. Those are really the 3 parts. When you say biosecurity, those are the 3 parts that really make up biosecurity. And so we get confused trying to talk about bioexclusion versus biocontainment, biomanagement, but the 3 things together are what we really look at. And we're going to have all 3 of those things in place to really meet the challenge of PRRS. And where we're still kind of lacking is both in the biomanagement, which would be having that ideal universal vaccine. We're still a long way from that, but biocontainment is a place where we haven't really spent enough time. The big companies have, because they try to segregate. If they've got a virus in this system and a different virus over here, they really try to keep those segregated. And Seaboard has done a great job of keeping viruses in their parts of their system and not letting them cross over into other parts of their system. And on the farm level, neighbor to neighbor, we've seen this litigation all of a sudden on PRRS in Indiana, and that's where a group of growing pigs were put in a facility about half a mile from a PRRS negative sow farm and broke it. They went through the elimination and then they broke again with another group. And so this lawsuit's been ongoing for some time. So we're really starting to be concerned about neighbor-to-neighbor biocontainment. If you have a virus outbreak, how do you keep it on your farm and not share it with your neighbor accidentally? And then maybe there's going to be legal ramifications in the future if we do, depending on the precedent set by this court case. So in other tools, the cotton rope, we'll talk about that. I said something about pad wrap. The thing to remember about airborne is it's not everywhere. Distance still is the best biosecurity tool that we have. If we're lucky enough to have our sow farm, I've got a farm that I got a financial stake in Georgia. We've been PRRS negative for 25 years now. And then got another one in Kentucky where I'm originally from. It's been PRRS negative since 2000. We did a rollover in that farm, and it's a 2000 sow farm with Cargill. And none of those farms are filtered. And so location is still extremely an important biosecurity risk factor, and distance works. The Canadians, a lot of those herds are negative, and it's because they sit in the middle of nowhere, as far as pigs are concerned. And I do think producers are willing to start working together, which is a big change. Farm closure and outbreaks reduce losses. If you keep adding negative gilts in there, you just keep stirring the virus, and it's still, we learned when I was at Premium Standard, the first thing we did when we started seeing PRRS activity, we just closed the farm. No more gilts. And a lot of times we'd close those farms for 200 days. And financially, it was the right decision because it really reduced the length of time the virus circulated in the farm and the length of time the pigs were viremic coming out the back door. So we've learned that. Transport innovations, I think 2008 or 9, National Pork Board sponsored a summit with all of the manufacturers of trailers, hog haul trailers, and we met with them and talked to them about biosecurity. And since then, the trailer manufacturers, all of them will build a biosecure trailer. And what is a biosecure trailer? That's a trailer you can clean. There's no hiding places. All the welds are complete. There's no channels where water can get. Everything is sealed. You can go in there and wash that trailer, disinfect it, and know that you didn't leave virus in the crevices and the cracks. So they all have those trailers now. It's just a matter of whether the industry is willing to pay for them. And I talked a little bit about the testimonials. Sequencing and mapping, that's become a big part of our, in the university setting, and Boehringer Ingelheim has done a lot. You know, these virus codes are like a family tree. And so we can track viruses for long distance, and I'll show you one that I tracked in a few slides. But it's helping us understand how this virus moves, not only in an area, but long distance. And so our ability to look at this has never been greater than today. Okay, a little bit about elimination, and you guys probably have sat through any of my talks. You've heard me talk about this before, but the old DPOP repop is truly, you know, was the industry standard to get rid of most diseases. In the late 70s, Hank Harris came along at Iowa State University, and he discovered that he could eradicate TGE without a DPOP, even on a continuous flow farm where normally that virus would just circulate forever. And so out of that understanding with TGE came the idea that we could do that with PRRS. And the viruses have some similarities, a lot of differences. But the old DPOP repop today generally costs you about $200 a sow place to do it. You know, it's variable, but it depends on the genetic source and a lot of things. But if you're going to do a DPOP repop in a standalone sow farm, it's going to run you around $200 a sow place to get it done. That's with at least 30 days down after the last animal leaves. And so that's extremely expensive. And not only that, it just kills your cash flow for a year. You know, so if you can't cash flow, you can't stay in business, and it's really hard to get back in business if you go through that process. You have to have more than PRRS before you do that. You know, you got to have APP and 3 or 4 other diseases that are killing you, and then along comes PRRS, and then you might make that decision, but normally we wouldn't today. Herd closure followed by negative gilt introduction. This is the stuff that we did while I was at PIC. We discovered that if we kept these farms closed from any introduction for about 200 days, then we could introduce negative gilts. And we did them with or without a off-site breeding project. And we were highly successful. We eliminated the virus from over 100,000 sows in that 98 to 2002 period, just using this process, no vaccine, no live inoculums, anything else. And today, those rollovers probably run you between $50 and $80 a sow place, a third to a fourth less cost than a DPOP repop. So if you got a single disease like PRRS, that makes a lot of sense. Tom Gillespie published a paper shortly while we were finishing up the PIC stuff. Boehringer Ingelheim supported Tom, and he published a paper where he used mass vaccination, followed by closure, followed by introduction of negative gilts. And that process seemed to work just as well. It cost a little more just because of you've got to go through and spend some money on vaccine and labor to get that two mass vaccinations done, and then probably more monitoring cost in that situation too. The LVI, the live virus inoculation that a lot of veterinarians are using today, that really shortens the length of an outbreak. And it also, we've used that as a tool to day one of our closure. We know exactly when every animal on the farm got the virus, and so it makes it easier to plan your rollover. And that doesn't add much cost because you're just using serum from an infected pig, and it is a little more cost. And then from my experience, and this was Cargill's experience, where they introduced gilts into their smaller farms quarterly, they discovered right away that all they had to have was negative gilts. If the farm was stable, when they put the negative gilts in, they would just roll negative, and that was quarterly gilt introductions. And that seemed to work really well in small farms. Also, I've had a lot of experience with small farms that batch farrow, and so if you've got enough time between your farrowing batches, it's really easy to eliminate PRRS. Even if you have growing pigs on site, a lot of times we can roll PRRS out of those farms without vaccination and without a depop or even a closure. And then when we were at Premium, we experimented with parity segregation, and we actually pulled that off one time. But that's when you have a system and it's parity segregated, all the gilts are feeding into one farm. And when you get everything stable and you got negative gilts, you just flow it into a sow farm and then reverse the flow. And we took, I think, 12,000 sows negative in a 20-week turn by playing around with that. So it's just another twist. Big producers can use that. But basically, the 200-day closure works in most farms. We have had the exceptions, and usually when we go in those farms, we either find a new virus circulating, a similar virus, or we find some really bad fostering techniques going on where people are bringing pigs back, trying to get that premium on that pig that, so suddenly you're weaning 6-week-old pigs instead of 3-week-old pigs, and those are the typhoid Marys that carry the PRRS back. So the devil's in the details. When you do one of these plans, you got to make sure you think of everything, and then you have to implement your plan. And like I said, the PADD risk assessment is a good way to benchmark your biosecurity efforts to farms that are other farms, and especially those farms that are staying negative and over time. And so that's something you should do. You have to plan the timelines. You have to adhere to the steps, but you also have to do enough monitoring and be flexible. You have to stay on your toes, and you have to react when things don't work and go right. But if you go through the process, it's a fairly straightforward deal to eliminate the virus, especially from standalone sow farms. And the big problem is keeping it out, and we know that. So now just get on to the meat of this talk, which is transport biosecurity. And we've known for a long time, many years, that transport has been incriminated with spreading infectious diseases. And in the circovirus outbreak in 2005, that outbreak really started in North Carolina. In 18 months, we spread that virus, which was a European version that came in probably, don't want to say it too loud, but probably from Canada, Europe to Canada, the U.S., and then it spread from North Carolina. In 18 months, we spread that virus all over the United States, almost everywhere, and that was done with trucks. That's most likely and logical way it happened. And so we know PRRS can survive on trucks, and all these tough hardy viruses like circovirus you can't kill with a flamethrower. PRRS is easy to kill. Parvovirus, another one you can't kill with a flamethrower. So those kinds of viruses, those really tough ones like circovirus, we were easily moved, even though we washed and cleaned and disinfected our trucks. We probably spread. And then there's a lot of we used to blame the blackbirds or the starlings for spreading TGE in the days when we had a lot of, outdoor farms. In all probability, when we look back, it probably wasn't the birds at all. It was probably just our trucks. And so, or primarily our trucks, how we spread it. And then the bacterial diseases. And we know from our experience in England when they got foot and mouth disease, which ended up, they destroyed over 1 million head of livestock. That came in the airport at Heathrow near London. There's a little guy that was picking up all the scrap stuff off the plane and fed it to his pigs, and that's how it got into England. And then the sheep haulers hauled it everywhere, all over the country. And the pigs weren't that affected other than that, the initial farm. But it was the trucks that hauled that FMD virus all over England, and it was a major disaster for them. And we really worry about that in the U.S. If that virus were to come here, it could destroy our industry if we really aren't prepared with the transport part of it. So this is my belief, next to the pig, direct contact, the trucks are our greatest risk factor today. And with PRRS, the breed stock companies got rid of the PRRS, and then a lot of the large producers are gradually getting rid of PRRS. So our genetic source is largely negative today. Our semen is largely negative today. So we've really kind of fixed the big problem, which was the pig and the semen, which is how PRRS is easily transmitted. And I think, although I'm all for filters in the right place, even though they're very expensive, but, in the wrong place, filters are not going to work unless you fix transport biosecurity. So we have to work on that. That's a place where we still have major weaknesses in our industry. And so there's been significant advances, though. We're making progress. Scott D has done a lot of that. He did a lot of the disinfectant studies. He's done a lot of the snowball for a health study where he put virus in a snowball and pitched it in the floorboard of his truck and drove it all over Minnesota, and they sampled it ever so often, and they got, viable infectious virus out of that snowball for days. And so we know that in the wintertime, our trucks that get covered with snow on the roads, if there's virus in there, it's going to stay there. So we've learned that. I had a part in this trailer drying and superheating things. The trailer baker was my invention, or sort of, and the idea came from others, but we built the first one. PIC built a couple. I got pictures of those here, so I should probably move on. But and I talked about the biosecure designs in the trailers. One of the big problems that we have, especially in large companies, is dispatching those trailers where you're trying to be extremely efficient with your drivers and your trucks. You want that truck to be utilized 24/7 if you can. And if the dispatcher's bonus is determined by how efficient he is with those vehicles, there's no way you're going to get him interested in biosecurity, because that just slows him down, gets in the way, downtime for trucks, things like that. That's not going to work unless you have someone that's focused on biosecurity and their bonus is based on not transmitting diseases, and that's pretty hard to do sometimes. But when I was at PIC, we were in the process of eliminating the virus. When we went to a all negative haul fleet, we never delivered PRRS to another customer, by truck. Before that, even though we were washing those trucks and trailers and letting them sit down for 78, 96 hours, we'd have pigs every now and then that would turn up positive in the isolation facility. And it was no question it was coming off a truck, even though we thought we were doing a better job than anybody else in the industry. So positive, negative haul fleets have been an important step during the elimination process for the breeding stock industry. And now they're all negative, so they're all negative haul fleets. So driver protocols, the driver is the greatest risk on the truck today. I'll just say that. They're the ones that contaminate the trucks. They're the ones that recontaminate the trucks. They're the ones that break the rules. They're the ones you got to watch, and they're the ones that we got to train. And we need to do a better job of that. Most of the people that deliver gilts today have got GPS technology in those trucks so they can monitor their routes, make sure they aren't spending 8 hours at a truck stop parked between 4 slaughter haul trailers and things like that. So monitoring by GPS has been a big step forward. And then we'll talk about truck washes and things like that. And I'm going to run out of time. But bottom line, transport can transmit any disease of pigs. We used to think clean trailers, if a trailer came and looked clean, it was good enough. We don't think that's right today. You know, that trailer needs to go through a process that sanitizes it and really sterilizes it, or it's a risk. So I think that this is the one area we really got to focus on. It's a controllable risk factor that we haven't done enough with as an industry and as producers. And so this is, to me, this is more important than filters, because I really believe the virus is transmitted far more often in a truck than it is by air. This virus is a wuss. You know, sunlight kills it, drying kills it, heat kills it. Every disinfectant will kill it if the disinfectant and the virus get together. I mean, it's easy to kill, and yet it's beating us to death, you know. And so because of that, though, we have the advantage that we can get it off of our trucks before we pick it. And I really believe a lot of these over-the-road truck washes probably disseminate more disease than they eliminate from the truck, because those things, a lot of times, you know, there's water everywhere, there's people going everywhere, drivers are out talking, and they get back in their trucks with wet boots, and so they track it into the cab of their truck, and then they get out, and when they deliver the pigs, and they get in the trailer and get the pigs off, and so, or, you know, they pick up pigs and get on the loading chute. There's just a huge risk, and it's because the system is kind of broken, and we need to fix that. So this is, when I was at PIC, a veterinarian in Georgia sent Bill Christensen and I a paper on this guy that was eradicating salmonella from poultry houses, and what he was doing, he was put one of these grain bin dryers in the poultry house and run it, try to get the heat up to 120, 130 degrees for 24 hours, and he could kill salmonella in that poultry house. And we started thinking, oh my, maybe we can do that with our trucks. And so we had some harebrained ideas and things, and we drew plans, and we played with this idea for a week or two, and then Bill got tired of it. And but there was a guy there named Ole Torgerson, and Ole really kind of championed the idea. And he built, with my oversight, we built this first one. That's 2 grain bin dryers. We backed the truck up to it, and what we discovered right away is we couldn't get the trucks hot enough, especially not in the winter. Even if we put the winter panels in, we couldn't get them hot enough. But what we did do is we dried the truck. It dried the truck pretty quickly, so they really started looking at drying as a solution. When I left PIC and I went to Premium Standard, we didn't have that luxury to let a truck sit around for 24 hours while it was drying to get PRRS off of it. We want our trucks to deliver a load, come back to truck wash, go through the cleaning process, and then go right back out on the road and haul some more pigs, either slaughter pigs or nursery pigs or something. So we moved on. We came up, and Dr. Becton was there, and in fact, Dr. Becton spent a lot of time validating this process. But the first one was a 4.5 million BTU heater, industrial heater, and we ducted this thing into a truck bays that were already in existence. We just retrofitted it, we insulated it, and we threw that thing in. And then, and I was a real believer. I thought, well, we can sterilize these trucks, and sure enough, we nearly could. And just a sensor, we read 8 heat temperature readings on that truck, 2 on top. This represents the trailer. And then 6 down each side of the trailer. And we got this thing up to 160 degrees, and we held it there for 10 minutes. And then we validated that we could, it killed TG virus, PRRS virus, E. coli, salmonella. And we even played around with some fodges that had the same thermal kill as FMD virus, foot and mouth disease virus, that wrecked, it was shortly after the deal in Great Britain had happened. And we were concerned about bioterrorists bringing that in. And it did a pretty good job against that too, although it didn't quite get hot enough to kill it all. We used a phage that the same temperature killed it as we couldn't use the FMD virus, in the field. But this was the first one that we built, and then we would run the duct right into the trailer, so we really superheated that trailer. It also heated the cab as well, and we worried about doing damage, but we did a lot of tests, and cheap PVC water lines in these trucks melted, but that was the only thing, and we didn't use them anyway, so we got rid of them. That way they just sagged and fell out. And, but anyway, out of that, AP started building these turnkey systems, and people experimented with these a lot, and you know, heat's expensive, natural gas, especially bottled gas, so people really tried to turn the temperature down from that 160, 165 that we validated to lower. And so a lot of these things run between 135 and 150. When I was in North Carolina, we tried to validate whether we were killing PRRS or not. And what we discovered was that 130, the virus survived almost every time in the right rear lower deck of that truck. And that's right where you put the sensor in the AP. And so since then, people have either run them up to 150 or they're doing it longer. They're heating those trucks for 20 minutes instead of 10 at 120 to 130 degrees. And that seems to be doing the same job. So drying or superheating, either one will kill this virus pretty well. And that's just their system, and they've got these, the truck goes in and then those things come out and blow right into the back of the truck, similar to the trailer baker where we used a flex duct and just stuffed it in there. And so there's a lot of these systems. This one, I think I took those pictures in Laurinburg, North Carolina as a Smithfield truck wash. So the only way, though, we're going to make this thing fully biosecure is to fix the driver situation. And I believe, you know, when you go through that process where you wash the truck out in one location and you move it forward to go through a truck wash and disinfection, and then you go into a heating bay, and then once it goes out of that heating bay, it's a clean zone. That really fixes the truck thing. But the drivers, if they've been in the truck wash and they've walked around with the guys that are washing and everything's wet, and they get back in the cab of their truck with their wet boots and their wet clothes, then they recontaminate the cab. But if it's done right, I believe that once that trailer has gone through the proper process and the driver's thing is, you know, the drivers go through the proper process, really when that truck backs up to the loadout on the farm, it becomes part of the farm, and the driver should never get out of the cab. And the farm people should load that truck, and now they can safely, and it takes the driver out of the picture. So, and nobody does that yet, but I believe philosophically that's the way we really need to go if we're going to go through this process with the trailers. So what needs to be done with drivers? You know, you got to keep accurate records. I think you got to fix this GPS verification is really good because it makes the drivers do what they say they're doing. They're not spending, they don't have a girlfriend in some other town where they spend a few hours there and leave their truck sitting someplace where other trucks can park next to them and whatnot. I just don't trust truck drivers now because I spent too much time with them. But anyway, you have to monitor and you have to verify that things are done right. And I really believe we need a national verification or certification program for truck washes. Because there's a lot of over-the-road truck washes that nobody really knows what happens there. You know, as long as the trucks come out and look better, we think we're okay. But there's so many little things that can be looked at and certified, just like separating the wash people from the drivers, you know, or having a clean place for the drivers to be while the truck's being washed. You know, there's simple things, but unless there's a certification, and then unless we as producers say, we're only going to use a company that goes to certified truck washes, then we have a possibility of fixing that. This is something we did at Premium. Once those trucks went through the whole process, we put that seal on the back of the truck. And if that truck backed up to a farm loadout, we empowered the farm people to turn it away if it didn't have that seal. Because that seal meant that truck had been properly processed and should be on the farm. But if it showed up without a seal, the lowest paid person on the farm was empowered to send it back. And we sent trucks back, and when we did, pretty soon the drivers became the best inspectors because they didn't want to have to go through the process again when they didn't have to. And so they really checked those trucks over to make sure they were clean. Inspection's important. You got to have somebody inspect. This was Lisa's cohort at Premier Standard. Dr. Beckton. This is not Dr. Beckton. This is one of her employees, and she inspected these trucks. I tell you, she was tough, and we really improved the system. So one thing, those of you that haul pigs and then do scrape out, don't forget that this is a real danger zone for you as far as tracking something back to your farm. So this is a real biosecurity zone, and if they're using recycled water, we had a deal in North Carolina where we were flushing these trucks out with recycled water, and we were tracking Actinobacillus pluridammoniate around, APP, on these trucks, and it was because we were contaminating the trucks with recycled water, and a lot of the pigs that were delivered there had APP, so any disease can be transmitted back to a truck from recycled water unless it's gone through some kind of purification process. A real danger zone. I think I talked about all this, but I believe that when you wash a truck in a bay, you really should wash the bay before the next truck comes in. To get the shavings out and get the organic matter out that's all over the place when you flush a truck out or blow it out and wash and disinfect it. So very few truck washes do that. They run them through as fast as they can, and that whole bay becomes contaminated with PRRS virus over the course of time, and it's easily tracked back onto the truck by the driver and the washers. And I think I've also talked about this, but one thing you do need is there needs to be clean and dirty zones in these truck washes, and the drivers have to observe those clean and dirty zones. And ideally, a driver would come to a truck wash in his truck and then change clothes and boots or outer coverings on the clothes and boots before he gets back. And while he's in the truck wash, he should probably shower through and then get back in his truck as a clean driver rather than a contaminated driver by wandering around in the truck wash. We don't do that, and it costs money and time, but unless we demand it, it's never going to happen. And so I think we need to. Thing about disinfectants, Dr. D did a lot of studies with disinfectants, and we talk about Synergize and Virkon being the very best two for PRRS. That's true, but any disinfectant will work if it's used properly and there's enough contact time. And the winter's our challenge. Both those two disinfectants I mentioned can be used with antifreeze to keep the truck from instantly freezing when it goes out. And we know if it does do that, the truck is still contaminated with PRRS because the temperature and exposure time for the virus is not long enough to kill it. So those are things we need to work on. And I think I've covered all the summary thing. I see Lisa's trying to get me out of here. But remember that the driver is definitely the biggest risk today if those trucks are going through a proper truck wash situation. And I'm going to continue on. This slide, I think, tells a compelling story. Each one of those blue dots is 25,000 hogs or pigs. And so it's pretty easy to see where all the hogs and pigs are. And it's pretty easy to see that in areas like this and some of these others that airborne would be a big problem. But remember, those same areas are the areas where we have the greatest number of trucks and the greatest number of pigs on the road and the greatest number of trucks going through truck washes. And so it can look like airborne when it really is the trucks. And don't forget that one. And then, have we got a couple seconds? This is a virus that I've been tracking. This virus came into Iowa out of Minnesota about 5 or 6 years ago. And every one of these little blue things is a zip code. And there's multiple virus isolates in each of these zip codes. Well, the interesting thing about this virus is it moved into northern Iowa and then moved down here into kind of central Iowa, and it's still active down here. But we always think and we always blame North Carolina of sending us the virus. Well, in this case, we sent them this virus. It came, and I can guarantee you, and we also sent it to Michigan out of Iowa. And I guarantee you those aren't airborne routes. Those are truck routes. And so our long distance movement of this virus is primarily by trucks.